Okay, let's unpack this for you. Imagine like a single pill, maybe, that could give you the benefits of years of really strict calorie restriction, without always being hungry or that incredible effort involved. That's kind of the promise, isn't it, of this fascinating compound called rapamycin?
It really is, and it has this absolutely amazing origin story, found totally by chance, in the soil of Easter Island, Rapa Nui.
Yeah.
And its journey from just an antifungal thing to being right at the forefront of longevity research. Incredible. So yeah, our mission today is to dive deep into the sources you've gathered, really explore its potential, but also critically assess the evidence, see what it all really means.
Right. So we're talking about mimicking calorie restriction. Maybe first, just remind everyone what exactly is calorie restriction and why is finding something to mimic it, a mimetic, so important.
Okay, so calorie restriction, or CR, it's essentially about cutting your calorie intake quite significantly, but crucially, without becoming malnourished. It's probably the most established non-drug strategy we have, studied for, over 80 years now? And it consistently shows it extends lifespan and, importantly, health span, how long you live healthily, across loads of different species.
Like those monkey studies you mentioned.
Exactly. The Rhesus monkey studies are landmark examples. Decades of research. They found monkeys on CR had like a 24% reduction in dying from age-related causes. That's huge.
Why did 24%?
Yeah. But here's the rub. Human adherence. Sticking to that kind of diet long-term is incredibly difficult for most people. Just really hard. And that creates this huge scientific push to find compounds, mimetics, that can give us those benefits without the extreme diet.
Okay, so that 24% figure really drives home the potential. And if CR itself is such a hurdle, how does this compound, rapamycin from Easter Island of all places, actually step in and mimic those effects?
Right. Well, the really compelling part about rapamycin is how it works. It inhibits a specific pathway in our cells called mTOR. That actually stands for mechanistic target of rapamycin.
Yeah.
And this mTOR pathway, it's like a central controller for cell growth, for metabolism, and yes, for aging.
A central controller, okay.
Yeah. So by damping down mTOR activity, particularly a part called mTORC1, rapamycin basically makes your cells think they're starving. It mimics that cellular state of low nutrients. And that, in turn, strongly switches on a process called autophagy.
Autophagy. That's the cellular recycling thing, right?
It's your cell's way of cleaning house, getting rid of damaged parts. Super important for staying healthy and potentially living longer.
That sounds almost, like a magic bullet. So if it mimics starvation, boosts autophagy.
Yeah.
Are its anti-aging effects basically identical to calorie restriction, or are there twists?
That's where it gets really interesting and a bit more complex. Well, both CR and rapamycin extend lifespan in many studies, and both induce autophagy. They don't work in exactly the same way. They're definitely using distinct molecular pathways. It's not just a photocopy.
Okay, so different routes to a similar outcome.
Kind of. And sometimes combining them can actually give bigger benefits, even additive effects on lifespan. There are studies, for instance, combining rapamycin with other compounds that show lifespan extension in mice up to 30% greater than either alone, which clearly tells us they're doing different things, complementing each other maybe.
30%? That's significant.
It is. But there are other key differences too. CR almost always improves insulin sensitivity, how well your body handles sugar. Rapamycin. Its metabolic effects are, complicated. Sometimes it can actually cause insulin resistance, especially at higher doses or in certain conditions. And its effects aren't uniform. They can depend on your genes, even your sex. Female mice often respond more strongly, for example.
Huh. Extending lifespan, but potentially messing with insulin sensitivity. That sounds like a major trade-off. How are researchers thinking about that as they try to, translate this to people? What do the human trials look like? And what are the big roadblocks?
Yeah, that trade-off is a central issue. Human trials are happening, but they're mostly looking at health span markers right now. Things like immune function, cognitive health, maybe even delaying aspects of menopause. Not directly trying to extend human lifespan yet. That takes decades to study.
Right. Measuring lifespan itself is tricky.
Exactly. And the biggest hurdle, honestly, is the lack of long-term human data, especially at the kind of lower, potentially intermittent doses you might use for anti-aging. We need that data because rapamycin isn't harmless.
Yeah.
At the higher doses used, say, for organ transplant
I
patients.
can confirm rejection, yeah.
Right. At those doses, it is known serious side effects. Immunosuppression, meaning higher infection risk. Kidney issues, potentially. And this is critical in some specific animal models, like mice that are already diabetic. Rapamycin actually made things worse. It reduced their lifespan.
Wow, so context really matters.
Absolutely paramount. Your individual metabolic state seems crucial. So future research is really focusing on finding the sweet spot. Optimal dosing, maybe low doses, maybe intermittent schedules, and also exploring combinations to get synergistic effects with fewer side effects.
Okay, so wrapping this up, what's the bottom line for you, the listener? Rapamycin is clearly this, really fascinating compound. It's right at the cutting edge of longevity science, offering a potential new route to healthier aging.
But the key insight here, I think, is the balance. It's complex. While the promise is immense, a powerful tool to potentially intervene in aging itself, we desperately need that rigorous long-term human data before anyone thinks about widespread use for anti-aging. And that metabolic context thing is just so important. It's a potent reminder that messing with fundamental biology needs real caution and, likely, personalization down the line.
Yeah, definitely not a simple picture. And maybe this deep dive leaves us all with a final thought to chew on. If we keep unlocking these aging mechanisms with compounds like rapamycin, maybe even combining them for bigger effects, what does a long and healthy life truly mean when we start having more and more tools to actively shape it? What choices will we make?